Well, good afternoon, viewers. Today we have a 2014 F150. It's here because the money light is on. Customer complaint is the transmission is going into limp mode. No. What does he say here? Sticks in gear. Transmission sticks in gear. Not sure what he means by that. I see a oil change message and check engine light on and check fuel fill inlet. This should be capless probably. So it's probably got an evap problem. So we're going to connect the scan tool to it and do a network scan of all the controllers and see what it has to offer for insight into why these problems are occurring. I haven't road tested it. I did start it cold and I noticed a misfire on a cold start and a significant amount of bluish white smoke. This is gas, so it's probably got valve seal issues or something like that. It's got 204,000 kilometers on it. So this is a new vehicle record. I don't think I've worked on this truck before, or at least not recently anyways, but we'll find out. Auto ID'd. Let's do a network code scan of all the controllers. I'm doing it running. Sorry for it. Catalyst efficiency below limit. Evap system, small leak detected. Output shaft speed signal. There's the P0720. That'll be the cause of the transmission not shifting. Output shaft speed sensor signal. Engine and transmission are the same computer. Airbag has a code. This U0401 invalid data received from the ECM PCM is probably due to the transmission problem. Invalid data received from ECM PCM. Key and switch circuit. It's probably got an aftermarket car starter. All right, so the code of concern is a P0720 and 722. Output shaft speed sensor circuit pending and no signal. So let's do a little research as to where that sensor lives and do a visual inspection of the sensor. So I loaded the vehicle in Identifix, and it's actually a 2013, not a 14 like I think I mentioned. And I did a keyword search for P0720, and there's a couple of cases on it, 391 cases to be exact. And the output shaft speed sensor is part of the transmission lead frame. It's inside the transmission on this thing. Now there is a TSB on it. Let's see what that TSB suggests. High gear engagement from a stop. Vehicles built on or before April 8th or August 4th, I'm not sure, 2013. Equipped with 6R80 transmission and built on or before 4/8/2013, may exhibit transmission engagement in 5th gear when starting. The wrench indicator and or seatbelt reminder may be illuminated. The speedometer reads 0 and the odometer displays dashes while driving. Symptoms may clear after an ignition key cycle. Diagnostic codes 720 and 722 may or may not be stored in the PCM. Replacement of the shift solenoids are not required. Molded lead frame. Yeah, that means pulling the tranny pan and dropping the valve body, I think. Warranty status. New vehicle limited warranty coverage. It's not a policy. It's not a recall. But that sounds like our problem. But the interesting thing is, when I look at, let's go back. Let's close this. And if I look at another case on here, back to the top, it mentions in this one, have code 720, 722. Transmission feels like it's stuck in third gear. First, check for any misfire counts in mode 6. It's not uncommon for the coil unplugged to affect the output shaft speed sensor and the transmission. If there are no counts, install a lab scope. So they're saying that a bad ignition coil can cause RFI, radio frequency interference, that can affect the speed signal. Install a lab scope on the output shaft speed circuit and check for hertz frequency and wave pattern. Look for excessive noise on the waveform. Noise will usually be caused by ignition or charging system. The hertz frequency will typically around 65 hertz at 30 miles per hour and should be steady when driving at a steady speed. If the frequency is jumping around, unplug the output shaft sensor. Well, that's not easy to do. And check the same signal coming in. If the signal is now good, suspect wiring issues between the sensor and the PCM. The signal is still erratic, suspect a sensor or internal transmission issue. And then there's that TSB. So I'm going to do a little bit more investigating here, but it's looking like it's going to need a lead frame, and we might as well do a transmission service while we have the transmission pan off. So we're going to scope the output shaft speed signal at pin 14 of that connector. The connector that I back pinned there, pin 14, is on the second row, third one in from the left-hand side of the vehicle, looking at it from the front here. And it's a brown-green wire. Now, looking at component testing in here, it says it connects to the TCM through the wiring inside the lead frame module assembly, uses output signal as an input for its strategies for shift TCC operation. It also uses it for transmission fault detection and diagnosis. It's a Hall effect type sensor that provides a signal to the TCM that changes in frequency as the rotating speed of the output shaft ring gear varies. TCM also compares output shaft sensor signal to the turbine speed sensor. So I think that TSS is turbine speed sensor signal to determine the gear ratio provided by the rear planetary. So that's checking it at the transmission. I'm checking it at the computer here because it's easier to get to. I'm curious as to whether we see any electrical interference on that signal. Now, this guide component test, it doesn't have any tests, so we're going to have to use a lab scope. Volts DC. I would expect it to be a 5-volt square wave. So I'll set the amplitude at 10 volts. Set the signal down here. Zero plane at the bottom, roughly. And half a second. So we're going to start it up and see what kind of signal we have on there. Shouldn't have any signal right now with it not moving because that's output shaft speed, so that's related to the transfer case speed. So I noticed we got a bias voltage of about 0.67 volts on that signal, and I would have expected it to be 0 or 5 volts at rest. I wonder if we got any AC ripple riding on top of it from a bad diode in the alternator or something like that. Make sure my ground is good. Well, let's take it for a road test and see what the signal looks like on the road test. So I decided before I cleared the codes that I would look at the misfire counters. And it's showing misfires on cylinder 3, 4, 5, 7. And this last drive cycle, it says a miscounted total of 10 misfires. Misfire events during latest cycle. Is it counting 14? I see 14. Because it is stumbling a bit. That's probably why the catalyst efficiency code is being generated. Probably the catalyst is contaminated now. Let's check cylinder contribution. Let's see if it shows a misfire. Functional tests. Is it under special functions? Relative compression test. Power balance. Come on, you can do it, Snap-on. I'm going to load this thing a little bit and see if it counts any misfires. Looks pretty smooth, and it feels pretty smooth. I probably invalidated the test by shutting it off and restarting it. Although it seems to be showing slightly weak on cylinder 3, but definitely not misfiring. Say if we kill injector number 5. Wow, that's slow. Let me try and exit out of here. An error occurred. Well, we're going to take this for a ride with this lap scope on the output shaft speed signal. So I'm going to graph data in the transmission side of the computer, output shaft, turbine speed. You can see the turbine speed and engine speed roughly mirror each other. The turbine speed sensor is part of the lead frame assembly too, I understand. I got the lap scope in the cab of the vehicle. We're going to go for a road test. So I don't know how well the camera is going to pick it up, but we've got a picture perfect square wave and steady output shaft speed signal, but it's not in limp mode now. So we're going to drive it for a while and see if we can catch it acting up. Might be better to graph the frequency instead of graphing the lap scope pattern, especially with this snap-on lap scope. It doesn't zoom in. So I'm going to use my Veris Edge to split screen and graph the frequency of the speed signal, and as well as watch the digital, or watch the data on the scan tool. So you have to go into the component test and view meter. And then once it loads the meter, we can get rid of this screen We get it to that screen, and we get a floating screen on there, so I'm going to get it set up. So I've been driving it for about 15 minutes. You see the graph on the bottom left is frequency, and at about 80 kilometers it's well over 1,000 hertz, so I had to switch it to 2 kilohertz. Graphing the frequency and graphing the actual speed in data in the background, and it hasn't dropped out. Now I can't recall from our conversation that I had with the customer if he indicated that it acted up when it was hot or cold or somewhere in between, but it's quite warm now and it hasn't acted up yet, so I'm going to drive it for a bit and see if I can get it to act up. So I called the customer and talked to him about this situation, and he doesn't say, he did say that it didn't seem to be related to any specific temperature. He said it acted up like crazy yesterday when he drove it to me, but I was sitting here idling talking to him on the phone, and this graph is connected to the output shaft speed sensor signal, and it's sitting at park, and this is what happened. I'm going to play it forward on screen here. It's started to produce an output shaft speed signal just sitting still, as you can see, and it lasted for about 10 seconds. Now I revved the engine up at that point and it didn't change. So it lasted for about 10 seconds, or 20 seconds. The screen is 20 seconds here. Interesting, because I was concerned maybe it had a bad diode in the alternator and a possible RFI signal from the ignition coils, but the truck didn't misfire at all. It didn't run rough at all. Now, I think that Hall effect sensor is failing. Now, interestingly, I don't recall if there's anything on the recording back here. I'm going to go back and replay this recording to see if there's a signal generated. That's this pattern right here. There was me revving it up. I'm going to look through it and see if I can find anything. So here's the recording of the data from the transmission side of the engine computer. This bottom left one here is the output shaft speed sensor signal, and you can see that after I stopped and was idling in front of the shop door, there was no speed signal input. Yet, if I look at the scope, the graphing multimeter showed a speed signal for quite a while. Let me zoom out. So you can see, here's where I was driving it. And then I was sitting there idling, talking. I was actually talking to him on the phone when it started to record a signal. Now, it's possible that the output shaft speed signal might not be displayed if it's not in drive. Because think about it, it wouldn't be expecting a speed signal if it's not in a forward or reverse gear. I had it in park when it was idling. So I think that output shaft speed sensor is failing. It's a Hall effect and it could break down. But I am going to check alternator diode ripple, and I might pull the coil off and have a look at the plug condition, because he has no idea when the spark plugs will be replaced last. So I got the Vantage Pro graphing the output shaft speed sensor voltage, and it's sitting at rest at 5 volts because obviously it's the other half of the square wave. And here's the alternator diode ripple. So there's no significant problem with any diodes in the alternator, at least not this instant in time. So would you look at this? This is the output shaft speed signal voltage, AC coupled at 500 millivolts. Now I'm running it obviously, so I'm thinking, is there electrical interference caused by the ignition or the alternator? The alternator diode ripple looks normal. But watch what happens when I turn it off. Okay, it goes to 0, flat line. Turn the key back on. Now it's obviously not ignition now because it's not running. So that Hall effect sensor is failing inside there as far as I can tell. At least I would think so, because it's not charging, it's not running, it should be flatlined. It's 0 now. It looks pretty clean there, but there's obviously some electrical interference in that sensor signal wire. I'm still going to have a look at a plug. So there's the spark plug out of number, let's see, that's number 1. It's on the passenger side front. It's a little worn, and they've been replaced before because I'm sure it didn't come with NGK spark plugs. So I think we're going to call the lead frame the output shaft speed sensor. Might recommend a set of plugs just for maintenance purposes, but I'm sure that that gap is quite wide actually. I wonder what the spec is. So we're down under here looking at this 6R80 transmission, and that's the electrical plug in the back of the tranny. There's no oil leaking out of this one. And the wiring harness isn't misrouted, hasn't been worked on. This is the level plug right here that you have to take out to check the level. I'm just looking at what's involved in pulling the panel on this. Looks like the panel comes straight down, provided all the bolts come out. If this was a Toyota, I wouldn't even want to touch it. It's not leaking anywhere. The wiring harness hasn't been tampered with. Looks like it's in its original place. So pull the pan off, change that lead frame, I guess. So I decided to take it for another road test. Note the static voltage on that speed sensor signal now, 3.9 volts. It's actually stuck in limp mode. It's going from 3.9 to 4.5, where it was a nice square wave before. So it's conclusive now. We caught it in the act finally. Got no frequency out of it. Or I got a frequency out of it, but the amplitude isn't good. It's not counting it. It's funny, the check engine light isn't on yet, but it's not shifting. Stuck in first gear. Okay, that's enough screwing around. So I turned around on the road here and it started working again. Nice 2.5 volt square wave, but the ground potential is not completely at 0. But the transmission's shifting again. That's funny. I wonder if it had something to do with a hot soak because I had it on the hoist and shut it off. You can hear the transmission is shifting fine now.